In the previous tutorial video, we actually developed this improved version of the console application for Circle. The improvement is precisely in two places. Number one, we try to call circle.getAreas, which is a utility method that we define in the Circle class, and it's called utility because of the static keyword over here. So we can simply say circle.getArea, and then we talk about the patterns for implementing utility methods in the previous video. So now, what we would like to do is, we would like to do testing. Testing is a very important component of your developments as a good programmer, as a disciplined programmer. Let's see how currently we can find defects or bugs in your code. Let's see currently how you can do it. For example, hypothetically, let's say when you first develop this particular getArea method, I know it's very easy to implement. It's really hard to really get wrong. Let's hypothetically imagine that somebody who actually implemented this getArea, they simply got it wrong. There's a logical error over here. So hypothetically, so let me just make a notes over here. Sorry, make a notes over here. So this is the correct implementation, right? Let me maximize it for you. So this correct implementation, and let's have a wrong implementation. Let's say rather than returning the area, let's say somehow the developer simply got it wrong. They simply return the parameter for the circle. So let's say area is simply equal to 2 times pi and times the radius, right? Even though it's the correct formula for parameter. However, it's not right for the area, right? So it's definitely wrong. Let's say we have a bug over here. So now, for you as a tester, how can you find it out? Think about it. All right, so now your answer should be, well, in order for me to find out, I need to launch Circle app number 2. I need to launch it, and then I need to manually try some input values over here. For example, if I try 10.0, just to make it very easy. So what do we expect to see over here? It should be 10 to the power of 2 multiplied by pi. It should be 314, right? However, it is not. It is not 314. So only when we actually manually invoke the console app can we actually test to see if the return value is the same as what we expected, right? So every time we want to test it, we want to launch the console application and do whatever we need. Think about a general scenario. For a realistic console application, you might get, let's say, 10 or 100 different input values to be read from the user. And then you might get very complicated computation over there. But now every time if you want to test your console application, what should you do? You need to explicitly launch the console application and manually enter the 100 inputs by your hands, and then find out if the produced output over here is really the same as expected by your eyes. That's really the problem here. It might be working for a simple application like a toy example, like a circle area calculation, but it's simply not going to scale. So that's really the critical point I would like to mention to you. So the way you actually test the utility method over here to see if that's really correct, or if you want to reveal some bugs from there. The way to do it is not really always to really just launch the console application manually. It might be nice for you to check a few input and output, but it's not really going to be the long-term solution. So that's why I want to show you a much better approach, which is called the JUnit testing. All right. And by the way, you might be wondering, we actually got the correct implementation and also we got a wrong implementation over here. Why would it be wrong? Wouldn't that just calculate using the correct implementation? Remember sequential composition, which means when you try to execute this block of code, it's going to go from top to bottom. Over here, it is really calculating the correct area over here using the right formula and store that into area. However, the next line, we're going to reassign this particular variable called area into the wrong value. So even though you had the right value once, but it just get overwritten, you just get wiped out. So that's no use. All right, so now for now, I'm just going to see exactly what's going to happen. Let me show you one more thing that might be useful. Let's say I just want to get rid of the correct implementation for now, but I might put it back later. you want to put it into comments, right? Remember when we talk about comments, one purpose for comments is for you to document your code. The second purpose, which is equally important, is to say temporarily, I'm going to put a block of code in my method or in my Java class to be no effects in terms of the execution. That's why I called to put it into comments. This is how you do it. Very easy. You can simply select this line or lines of code, and then remember how you do the put it into comments. Control/. If you're using Mac, it will be Command/. Okay, if you do that, it's going to put whatever block of code, either single line or multiple lines, into comments, right? How do you remove it? Let's say I want to put it back. You will simply, again, highlight the line you want to remove the comments, and then Command or Control/, and then it's going to put it back into effects. Okay. Let's say now we want to show exactly how you can do JUnit test to really make the testing process much more automated, so you don't have to manually launch the console application each time. Because after all, our purpose really is to really test this particular method, which the console app2 depends on. All right. How do we do it? So now let's create a JUnit test. This is how you create one. Right-click on the source, and then say New, and then choose JUnit test case. And then make sure you do not select the new JUnit Jupyter test. That's not the version we're going to use. Choose JUnit 4. And then you want to type a name for the class. So typically you will start with the prefix test. And then what class are we going to test? We're going to test the circle. So circle over here. As far as this course 1022 is concerned, we wouldn't be expecting you to really write JUnit tests. However, we will expect you to read them. Right? That's something I will show you hopefully in almost every week of the tutorial video. I'll show to you. All right, so I'm just going to say finish. For the very first time, it's asking whether, first of all, JUnit 4 is not in the build path. Would you like to add it? Yes, you want to. So perform the following action: add JUnit 4 library to the build path. Say OK. All right, so now this is our JUnit test. Okay, I'm gonna go over the JUnit test in more details in the later week. But for now, let's just write something for you to test. Basically, think about each test method. Void simply means we don't return anything. Remember, in the getArea method, we actually got double as the return type. But if you say void, that means the test method does not return anything. Let's now simply try this. We just want to calculate, for example, we can say assert, and then you can control space. Yeah, assert equals over here. We want to compare two values over here. You got something called expected, you got something called actual. Remember, expected is something that we thought in our mind what should be really the actual output, right? So now remember we got 10.0. So the answer should be something like this. Should be 314.0. That's what we are expecting to see. And then the actual value is what's returned from the utility method. And let's call that. We can call the method in the same way as we call from the circle application 2. We can simply say circle.getArea. Let's go there. Circle.getArea over here. And then let's say we want to try the 10.0 that we tried before, right? So now, whatever that's going to be returned, for example, currently, is going to be this number here, 62.80, which is wrong. It will be compared against the 314.0, okay? However, you can see we actually got this particular usage should be obsolete because when you are comparing two floating point numbers, the comparison cannot be exactly precise. Let me just make things short for you over here. So to really represent decimal numbers, the underlying binary system for your computer cannot really faithfully represent the decimal number. So that's why you always should really allow some tolerance. So we wouldn't get to the details in this course. Okay, so what you typically can do is we allow certain discrepancy between the two numbers. For example, 0.01. So we are saying that whatever value we are expecting and whatever value that will be returned from the actual method we want to test, the difference between them cannot be more than 0.01, right? And the assert equals, you can think about assert is to verify if the result. Think about this here is corresponding to the manual action I just performed. Remember, I type in this number over here, and then internally is going to call the method, and then once this is returned, I need to compare to see in my mind, like also by using my eyes, to see if 62.80 is really the same as 314 over here. That's manual process. But now in the JUnit test, we can simply write this as a method call, and then every time we want to test if our circle calculation is correct, we can simply rerun the JUnit test. Right? That's the kind of the idea. All right. So now let's see how we can run the test. So we'll simply right-click on test circle, and then you can say run as JUnit test. All right. If you do that, it's going to show you, okay, it's a red bar. So red bar simply means there's at least one failure for the test. But now we only got one test method. That means it fails, right? And then you can see a little bit more information over here. So if you click on this test actually failed, you can see there's a failure trace over here. Look at this over here. Expecting 314, that's the correct result, but we are getting 62.8. Remember, that's the value we got previously, right? So now, every time I want to really rerun this test, all I need to do is I can simply hit on run over here. It's going to tell me red bar. I don't really need to compare with what I had to do in the beginning of the video using console app, using Circle app 2. I needed to explicitly, let me demonstrate it again. I needed to explicitly launch the console application, manually type the input value I want to test, and then compare this actual value against the expected one, which is 314. The more test cases I need to run, the more frequent I need to do this manual process, which is definitely not going to scale for us. So that's why we just have to say circle over here and do it, right? And then do the method over here. All right, so that's about, okay, sorry, there's the test case over here. Okay, so that's the first method. We can just do one more, okay? I can simply just copy and paste over here. So I can name this test 1 and also test 2. I can just try a different number. So you can now, if I try a different number here, it's like a different launch of the console application correspondingly, right? So why don't I simply put 20.0, okay? So what should this value be, right? I can be a little bit smarter here. I don't need to calculate it separately. What do I expect it to be? It should be 20.0 times 20.0 times 3.14, for example. I can even make it more precise. As long as the return value over here is going to be within 0.01 difference compared with the expected value, I'm okay. Right? So now what I want you to get used to is this part over here is the expected value, the correct one. And this part here is the return value from the implemented method. As long as the difference is within this particular tolerance, like an epsilon, then we are okay. All right, if I rerun it over here, you can see now we got two methods. Not surprisingly, they both fail. All right, let me see how we can fix it. If I go back to the circle over here, let me simply select this block over here, Command or Control /. I put the wrong implementation into comments over here, right? So it's not going to be executed anymore. It's not included for execution. So now we only got the correct implementation. And make sure you save the file so it will be recompiled. Now if I run over here, we still fail over here. So let's go back here. So did I write something wrong? To figure out, let's look at the error message together. Remember over here, let's click on test number 2 and let's look at the under the failure trace over here. Expecting 1256.63704. That's the expected value. That's the result from using this very precise pi, much more precise. Remember, for the calculation, if they get area, we only used 3.14, right? But this is still correct, just less precise. And now the actual calculation is going to give to you 1256. Basically, because we are using 3.14 over here, that's why we're getting less precise after the decimal point, right? So you can see in this case, we can judge to see how we can fix it. You got two possible ways to fix it. Either, let me show you here. Either you can simply change the implementation over here to be 3.14 and whatever, with more digits after the decimal, or we can now be more tolerant on the result. Let's go back to the test over here. So now, rather than having the tolerance to be 0.01, we can have just 1. So we can change this to be 1 and change this to be 1. You can think about this is like a plus minus 1 range for tolerance. All right, so now let's run the test again. So now this is going to be green bar. So that means both results are actually correct. You can see as we try putting more test cases over here, each one of them, you can think about each test. Let me just write the comments here for you. Okay, it's /*. Each test method represents or corresponds to an manual launch and interaction with the Circle app 2. So now you really want to pick up the point over here. It's really manual. However, now once we define the methods over here, once and for all, once you run the test over here, it's going to be immediate to see the result, right? So that's really the beauty about JUnit Test. We're going to see many more features and many more examples about using JUnit Test, but it's only week number 1. We just want to show you the introduction. So why should you know? Know about why we're using JUnit Test, why it would be better than simply using a console application. You can still using console application to test your software, but just know that JUnit Test is actually a better way to automate the test cases. Okay. Finally, I would like to just show to you very quickly about the code structure. All right, so now let's switch to the notes. So again, we are showing something very similar to this dependency structure as we've shown before. Remember, in the case of the Circle app 2, remember on the one end, we actually got the Circle app 2 over here previously, right? And that one there actually got 2 uses, or in general, as many uses as you wish, that will call the Circle utility method getArea. And now we got something very similar. So let me tell the conclusion right away. The fundamental difference between Circle app 2 and also test Circle over here, the difference is one is printing to the console using system.out.println. The other one is really trying to make some assertion over here to really check to see whether the expected value over here will match the actual value that's returned from the method. So they are serving different purposes. For this one over here, it's kind of a more fun to actually program with because you can interact with the console using keyboard. On the other hand, this one here is a much better practice for software engineering, in which case you can simply automate the testing process, right? So they are serving different purposes. So now let me show you again why we got the dependency over here. We got 2 usages of calling the methods. You can see under test 1 method here, we are calling circle.getArea and we are passing one input value 10.0. And then with the second call over here, we say circle.getArea and then we are passing a different value over here, right? So now we're going to follow a very similar pattern, right? So now for the blue one, we're basically, very quickly. For the blue one, we're let me just make it a bit thinner. So the blue one, we are calling this getArea method over here with 10.0. Every occurrence of radius is going to be 10.0. And then it's going to calculate the area accordingly. And it will be returned back to be compared. So this will be whatever value that's returned from here is going to be some value that will be compared against the expected value, which is 314.0 in this case. And let's see the other one, the second call. We're calling the same method with 20.0. So we are calling getArea for the second time, 20.0. Accordingly, every occurrence of radius is going to be replaced by 20.0. That means we're going to calculate area accordingly, and then you can think about this part here is also going to return some value over here that's different, and then this will be a compare against the evaluation for this expression here. They will be compared against to see if they match, right? Hopefully you can see the structure over here. Again, it's very similar between the two. Let me write it down for you. you want to compare the console app versus JUnit Test. So here, console app can just be the circle app number 2. So what do they share? What they share in common, which I'm going to put over here, is they call utility methods. So now, in the case of console app, it's actually going to print, let's say, compute and print values to console, right? So after certain calculation, after getting the result, we're just going to print to the console, right? That's what we did previously. On the other hand, so what about the JUnits? It's actually going to once we call the method, we're going to compare, return values against the expected value for the testing purpose. You can see over here, whatever you return, you want to make sure it matches whatever that's being expected. Okay, one more note to say. Very importantly to note, this process here is really completely manual for console app. However, for JUnit test, it's completely automated once you have defined your tests. So this is really some important comparison you want to bear in mind between the two approaches. Both are important, you should know both.